Thank you for watching Science TV. This is Ilya Barukcic, Jever, Germany. It's December 2009 after Christ. Heisenberg's uncertainty principle has at least two meanings. The first meaning is the physical meaning, and the second meaning is the philosophical meaning. Heisenberg formulated his uncertainty principle 1927 while he was working as a lecturer in Niels Bohr's Institute for Theoretical Physics at the University of Copenhagen. In his celebrated paper published in the year 1927 concerning the uncertainty principle, Heisenberg did not publish a very precise definition, or better to say mathematical derivation of his uncertainty principle. It was Kennard himself who published in the year 1927 a very precise mathematical derivation of Heisenberg's uncertainty principle. Kennard's mathematical formulation of Heisenberg's uncertainty principle was accepted by Heisenberg himself too. Allow me to refer you on this account to Heisenberg's publication at the University of Chicago Press. Roughly speaking, according to Heisenberg's uncertainty principle, for position and momentum, exact simultaneous values of position and momentum of a quantum mechanical object can be determined only with some uncertainties. In last consequence, the more precisely the momentum of a quantum mechanical object is given, the less precisely can one say what its position is. Insofar, we are not able to assign exact simultaneous values to the variables position and momentum, even in principle. If we rely on the principle of causality, the same presupposes that exact simultaneous values can be assigned to all physical quantities and even to such like position and momentum of a quantum mechanical object. Heisenberg's uncertainty principle is regarded or considered as the fundamental principle of quantum theory and of our today's understanding of the physical world. Just few lines before, mathematically it is not completely clear how Heisenberg derived his uncertainty principle, his famous equation number 1. Heisenberg formulates his uncertainty principle in the following German words. This can be found on page 174 of his original paper. Im Augenblick der Ortsbestimmung, also dem Augenblick, in dem das Lichtquant vom Elektron abgebeugt wird, verändert das Elektron seinen Impuls unstetig. Diese Änderung ist umso größer, je kleiner die Wellenlänge des benutzten Lichtes, das heißt, je genauer die Ortsbestimmung ist. In dem Moment, in dem der Ort des Elektrons bekannt ist, kann daher sein Impuls nur bis auf Größen, die jener unstetigen Änderung entsprechen, bekannt sein. Also je genauer der Ort bestimmt ist, desto ungenauer ist der Impuls bekannt und umgekehrt. This is Heisenberg's first formulation of his uncertainty principle In broken English, at the instant of time when the position is determined, that is, at the instant when the photon is scattered by the electron undergoes a discontinuous change in momentum. This change is the greater, the smaller the wavelength of the light employed, i.e., the more exact the determination of the position. At the instant at which the position of the electron is known, its momentum therefore can be known only up to magnitudes which correspond to that discontinuous change. Thus, the more precisely the position is determined, the less precisely the momentum is known, and conversely. According to Heisenberg's uncertainty principle, we cannot know position and momentum at the same point in space-time exactly. Mathematically, Heisenberg formulated his uncertainty principle as follows. This can be found in his original paper on page 175. P subscript 1 times Q subscript 1 is about h. This is Heisenberg's famous equation number 1. This is his original formulation of his uncertainty principle. It is known that P subscript 1 denotes something like the mean error of the momentum P, and Q subscript 1 denotes something like the mean error of the position Q. It is important to mention that Heisenberg formulated his original uncertainty principle in terms of something like an equality, but not in terms of an inequality. The first mathematically exact formulation of Heisenberg's uncertainty principle in terms of a non-strict inequality is due to Kennard, as mentioned some seconds before. This is equally the reason why Heisenberg's uncertainty principle is sometimes called the Heisenberg-Weil-Kennard inequality. Heisenberg's uncertainty principle for position and momentum was derived by Kennard as follows. Sigma of x times sigma of p is greater than or equal to h divided by 4 times p, where sigma of x denotes something like the standard deviation of the position of a quantum mechanical system, where sigma of p denotes something like the standard deviation of the momentum of a quantum mechanical system, where h denotes the well-known Planck's constant h, and p denotes the mathematical constant p. Thank you for watching Science TV. This is Ilya Barukcic, Jever, Germany, December 2009. Bye bye.